Hello, I am Javier Saavedra, and today I'm going to talk about my professional practice. My professional practice was in a research group called Green Technology Research Group that works in investigation for Faculty of Engineering and Applied Sciences of Universidad de los Andes. The objective of this project is to produce the compounds of interest that they are hydroxyacid by genetically modifying the bacteria Pseudomonas lata and Ralstonia eutropha. Both bacteria can produce a PHB when they have available carbon source and they are in absence of nitrogen. So the idea is to modify it so we can produce the hydroxyacid. Why we want these hydroxyacids? We want it because they can be used to produce hormones and drugs and antibiotics and skincare products. So the work that I did, the objective was to genetically modify Ralstonia eutropha by deleting the PHAC gene, that is this one here. So to achieve that, we have to follow the procedure that we want to transform it by conjugation, then select the bacteria, and then we did a confirmation. So we did 3 series of experiments. One was very long and unsuccessful, one was very short and unsuccessful, and one was successful. The successful one followed exactly that rule, the conjugation, the selection of the bacteria, and then the confirmation by PCR. The conjugation works by putting 2 bacteria together, Ralstonia eutropha, that is the one that we want to modify, and then Escherichia coli, PFS51, that it's the one that has the gene that we want to put in Ralstonia. So we put it to grow together, and when they grow together, Escherichia coli trespass this plasmid to Ralstonia eutropha, and then Ralstonia eutropha, when she's growing, she start to applying the plasmid to its gene. So in this plasmid, delete the PHC gene. We did this experiment, and the thing that was most complicated was the conjugation. In this one, it did not work at all, and in this one, we don't know if it worked, but maybe the selection pace was wrong. So the conjugation or the selection was difficult. But with the good results, we have here a plate with LB medium, here with LB plus tetracycline medium, and then the confirmation PCR. So we want to have a colony that is not in the LB plus tetracycline, that it is growing in LB alone, and that has 1,000 pair of base, that is the marks that are in the equal of this one. So we have these 2 that were very great marks, and they have a great growth in this plate and not grow in this. So we took that both of those bacteria and storage in the refrigerator at minus 80 degrees Celsius. That's what my investigation. The idea is to use that bacteria after to keep modifying it so they can be used in this project. Thank you. That was my presentation. Goodbye.